All right, we are now recording. Let me get my PowerPoint back up. Okay. Then we're going to get the slideshow set up for PowerPoint. But let me make these announcements first. Thursday afternoon, Friday, over the weekend, I was able to get your syllabus updated, and I put it out on Blackboard under content, so it's there now. I'd already updated the research paper instructions, and I put those under content in Blackboard. I got my locator card done. It's in content on Blackboard, okay? And let's see, I meant to call roll before I did this. I just reminded me I didn't call roll. Let me get that in a second. In fact, let me do that now, and then when people are coming in, they will get to hear the announcements. Sorry about that. In fact, I think what I'll do is pause Screencast-O-Matic. It's so much easier to say Tegrity right there, because there's no reason that I have to record the roll. Okay. Now, Joseph Daniel Adams, we never had seen. Is he here? He's no longer showing up on the roll, so I assume that he did a drop ad or something. Uriel. Okay, thank you. All right. Jackson. Got it, thank you. Trey. Trey not here? Trey Armstrong. Okay. Shelby. Shelby not here? Okay. Caleb. He came the first day. We didn't see him Wednesday, but his name's no longer on the roll, so I assume he's changed to another section. Colton, right? Okay. Slowly learning names and faces. Emphasis on slowly. Okay, David Brown. Got it. Thank you. 29. Okay. Josh Brown. All right, good deal. Aaron Buchanan. Got it. Thank you. Krista. Yeah. Thank you. All right. Now, this name was added when I went to do roll, so I haven't seen her yet. Takia Marsha Franklin. Is she here? Okay. Alexis Freeman. Okay. And good deal. Frank. All right, good. Thank you. Justin Jordan. All right, good. Thank you. Kayla. I saw you earlier. There you are. Okay. Peyton. Peyton Knight. Okay. Jalen Lee. Okay. Okay. Gotcha. I found out there's two Jalen, one with a D and one without. Chris Lynn. Okay. Good. Thank you. Craig Martin. Okay. Good. Thank you. Curtis Martin. Curtis not here yet. Sabrina. Okay, thank you. Ricardo. Okay. Kara. Okay, thank you. Nathan. Good, thank you. All right. Second page always does well. Okay. Kiana. Good, thank you. DeAnthony. Thank you. Sarah. Good, thanks. Shay. Good, thank you. Josh Smitherman. Okay, good, thank you. Colton Turner. Not here. Jalen Underwood. Got it, thank you. Tay. Okay, good, thank you. And Brandy. Good, thanks. Anyone whose name I did not call? All right, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 9, 12, 14, 16, 18, 26. All right. Okay. Now let's start Screencast-O-Matic back. And let me go over what I was saying. I've got the syllabus, instructions for the research paper, and my locator card all on Blackboard under content. I also got the PowerPoint shows, static PowerPoint shows for every section we could possibly do, I think, in this section. Probably more than we'll cover in this term, more than we'll cover, but I wanted to make sure we had them all out there. So those are out there. I also found it seems like maybe 3 sites that either I had discovered or students had discovered and said they found helpful. I'm trying to remember the names of them. Education Portal, I think, was one. Prof. Rob Bob was one. And seems like there was another one. I can't remember. So I don't have Khan Academy's address. So if you've got something you like from it, send me the link and I'll put it out there too. I've seen some Khan Academy stuff before, but I didn't get it on this. Can I get your name, please? Peyton? Okay. Okay, I know. Oops, there it is. There we go. And name, please. Nathan? Huh? Okay, I'm hard of hearing.
James Turner.
Oh, okay. One more time.
James Turner. James, J-A-M-E-S, Turner.
James Turner, okay. All right, I'm hard of hearing. There we are. There you are. Okay, you go by James or Colton? Okay, all right. That's what was throwing me. I didn't remember a James in my class. I thought, I know I've seen you in here before. Anyone else whose name I haven't called? Okay. Thank you. Okay, so the Blackboard's up, the PowerPoint's up there, and also a few sites, and if you're getting me that one from Khan Academy, I'll put that up too, okay? That's all on Blackboard. Okay, now, the first 2 classes that I recorded here, I tried to move those to Blackboard. They were too big. So the recommendation is put it in YouTube first and then put them up. Just do a link to YouTube. So I tried doing that. After an hour or 2, it came back and told me it was too big for YouTube. Well, then I found out that you have to verify your account before they will let you go over 15 minutes in YouTube. So I tried that and it bombed. Well, over the weekend at home, to do that you had to have a mobile phone and I didn't. So when I got home, my wife has a mobile phone, we used hers, and then when I started doing it, I found out you didn't have to have a mobile phone, but they told me you did. So anyway, I got that. Those classes are now out there on YouTube, but I wasn't able to get the link to link in the Blackboard. I'll try to get that done today, okay? And hopefully today's class will go straight to YouTube, and then I won't have that intermediate step, but it still won't be on the link until I get it there. Now, when I do get it there, what I've tried to set up is what they call a playlist. And the playlist for this course is Math 100 Fall 2016. Okay? You'll see that from what I understand, you get to see all the things I've recorded. So you can see my Math 112, you can see my Math 126, my Math 227, my Math 237, and my Math 238, okay, up to differential equations. You can watch them all, okay? I don't know that any of you would want to, but that's why I put it in the playlist so you can just go to that one and not, have to search through all the others. They say that works pretty nicely. I haven't been able to verify it because I haven't been able to link yet. All right, any questions? Sorry that took way too long. Let me get this. Probably it doesn't look any different from you, but it does to me and what's on my screen is what you see on Screencast-O-Matic. So I'm fixing it so you'll see what's up here. Because that wasn't what was on my screen. Now it's the same on both screens. All right. Any questions on anything we've done up till now? School-wise, course-wise, Blackboard-wise, or math-wise? Okay. Any questions? All right. I think this is where we left off before. In general, factoring is the reverse of multiplication. I hope I said that before. You know, you factor 6 is 2 times 3. Well, you just undone your multiplication. Those are the factors because 2 times 3 is equal to 6. The distributive property to find the product, that's not a good sentence. The distributive property is used to find the product of a monomial and a polynomial as shown here. Okay, can y'all do that multiplication? That first one. 3 times x plus 2. What does that give you? 3 times x plus 3 times 2. Most of us don't do that step. We go straight to 3x plus 6, right? Okay, how about this one? Got it. Okay, how about this one? X cubed plus 6x squared minus 4x. Y'all are really good. Okay, so this is multiplication. Guess what factoring is? Going from this column to that column. Okay, undoing the multiplication. Yin and yang. Okay, this multiplied it, factoring unmultiplies it. And what's unmultiplication? Division, exactly. So factoring is basically a form of division. But with polynomials, later we'll talk about dividing polynomials, but you're doing this kind of in your head. Okay? And what we're doing is greatest common factor. So far, that's what we're doing. Any questions on this? Okay? Now, we'll also use the distributive property. This is how we did it before. A times B plus C is AB plus AC. But guess what? That equal sign goes both ways. So you can do it this way. AB plus AC, factor out or divide out the A, and then what you have left, B plus C. Reverses that process. So the distributive property works both ways. An equal sign is bidirectional. Okay? It can go either direction. Okay? And that's what we mean by factoring. So guess what that is? 3x plus 6? X plus 2. Very good. Next one? 5 times 2x minus 1? Is that what you said? I thought so. Okay. All right. What would that one be? Greatest common factor is x times x squared plus 6x plus minus 4. Perfect. Very good. Any questions on that? See how it's done? Okay? Fairly straightforward. If you have questions, please ask. Okay? Because math builds on itself. If you're fuzzy back here, it's going to get fuzzier the further you go. So please ask. Note that in each of those examples, a given polynomial has been factored into the product of a monomial. What do we mean by monomial? One term. Remember, nomial means name or term. Mono means one. Y'all know what a monocycle is? That thing that I don't know how they ride, one wheel, you know. You seen them ride that? Anyone know what the Planters peanut wears? A monocle, exactly. Not by, two eyes, it's just one. Mono means one, okay? And what you have left over after you factored out the monomial is a polynomial. Polynomial meaning many terms. Some of those are 2, some were 3. Many terms could be as few as 1, okay? Obviously, polynomials could be factored in a variety of ways. Okay, here's one. 3x squared plus 12x. How would you factor that? Pull out a 3, and what does that leave you with? Oh, but here somebody else wants to pull out a 3x. And what does that leave you with? Yes, x plus 4. Very good. There's several ways you can factor. You could have factored out like you just suggested. The biggest common factor, greatest common factor, 3x, that left you x plus 4. You could have just been lazy and pulled out the 3, and that left you x squared plus 4x. But guess what? You still got another step to do and factor out the x. Or you could have factored out the x and left it 3x plus 12. Or why would you do this? Factor out a 1/2, and that gives you 6x squared plus 24x. Is that even right? It's right, but who would want to do something like that? Okay? Because sure enough, how can you tell if it's right? Go back and multiply and see if you got what you started with. 1/2 of 6 is 3x squared. 1/2 of 24 is 12x plus 12x. So yeah, that works, but why would you want to do that? That's not a smart move in factoring, but there's infinite number of ways to factor. We are, however, primarily interested in this first method of all these factorization forms, which we refer to as completely factored form. Okay. A little bit of time out here. The polynomial is completely factored. The 3x, yeah, you could say that's 3 times x. But you know, with a monomial, we leave all those terms together. And we count that as completely factored. Okay? This one, you could factor something else out of the polynomial. This one you could, and this one you certainly could. So we don't want to leave the polynomial with anything else you can factor. Okay? Now, if it takes you 2 or 3 or 4 steps, fine. Take as many steps as you need so you can see what you're doing. But you want to get it down into completely factored form. Any questions on that? All right. A polynomial with integral coefficients. What does that mean? Second? You may have said it right. I just don't hear well. Someone said something. Okay, I'm hearing things. Weird. Okay. All right. I thought someone may have said whole numbers. Is that what you said? It's what it sounded like. It's pretty close. Yeah, okay, I thought that was it. Okay? All right. An integral is almost a whole number. Okay? The only exception to it, whole numbers are always positive. Integrals can be plus or minus. That's the only problem with that. But you got the right concept. An integral is not got a decimal. It's not got a fractional form. Okay? It's no square roots or anything else. Those are basically the counting numbers plus and minus. 1, 2, 3, 4, 5, 6, 7, negative 1, 2, 3, 4. Okay. Those are your integers. Okay? So a polynomial with integral coefficients is in completely factored form if it meets these two conditions. Okay? It's expressed as a product of polynomials with integral coefficients. Guess what? This one fails right there because now we pulled out a fractional form when no fraction existed here. So if you have a polynomial with integral coefficients, don't go introducing any decimals or fractions unless there's some really good reason to do so. That won't be in a completely factored form anyway. Okay? So it's expressed as a polynomial, a product of polynomials with integral coefficients. Not fractional coefficients, not decimal coefficients. But of course, the whole polynomial had to have integral coefficients to begin with. Now, number 2, no polynomial other than a monomial within the factored form can be further factored into polynomials with integral coefficients. That's what we said. That's why we said this one wasn't done because you had the 3 out, but you didn't pull the x out. Here you pulled the x out, but not the 3. So you have to leave it in a form so the polynomial cannot be factored any further. Okay? So that's what we mean completely factored form. The monomial, yeah, it can, but as long as it's a monomial, we're happy. Okay. Do you see why it's only the first of those previous ones was completely factored? Right? Okay, sorry. Say that one more time. Yeah, oh, absolutely. I usually close it. Whoever came in last probably. Thank you. Of course, you can do that anytime, something like that. All right. Good deal. All right. In each of the other three forms, a polynomial inside the parentheses could be factored further. So that's really the key. Moreover, in the last form, you pulled out a fractional form. Don't. Only have integral forms. Okay, the condition using only integral coefficient was violated. But the big deal is this could be factored further. Okay, so always have it so the polynomial is in the simplest form you can get it. And that's the other way we talk about this simplest form. Okay, here's example one. I hate that they do the work for you. You do the work and don't read my hand. Okay. Can you factor 4m cubed plus 8m fourth n? How? Say again? 4m cubed is the greatest common factor. And what? Whoa! They missed it, didn't they? Oh, shame on them. Okay, and what's next? Once you fill out 4m cubed, not 4m squared, what do you have left? Say again? No. You have a 1 left. See, they messed it, okay? So let me do it correctly here. Shame on them. Whew. What were they thinking? I don't think they were thinking. Okay. Shame when the book does a mistake this bad to begin with. All right, now, what I've got to do, this makes such a pain, okay, is get my pen activated and then change my color to black. Okay. What we have here, they did okay, but they don't have it in completely factored form because there's an m in both terms here. So this would be 4m cubed. Y'all said that. But I didn't hear someone tell me what's left over. If you factor a 4m cubed out of 4m cubed, what do you have left? 1. Okay, maybe someone said it. I couldn't hear it. 1 plus what? 2 m n. Excellent. Excellent. Way to go. Now, do you know if you're right or not? Okay? I am such a, I guess, anal retentive about things. I want to make sure I'm right. So how do you check this? Multiply. And what do you get? 4m cubed? Yeah, perfect. Just multiply it back. If you don't get what you started with, hey, error. Okay, good deal. All right, let's do this one. Can you factor that? What? 8? 8pq. And when you pull out an 8pq, what you have left? 4p q to the third. Right? Plus 1. You got it. Excellent. Any questions? Am I blocking your view when I'm doing that? Okay. Well, no, I can't cover this side from over there without covering it all. All right, how about this one? Anything we can factor out? 4 x squared y squared. 4x squared y squared. Perfect. And what do you have left? I'm sorry. Oh, they messed it, didn't they? Oh, wait, I didn't read the instructions. Good thing to read the instruction. For each of the following, determine if the factorization is completely factored form or not. We said no. We said they missed it, but no. The question answer was no here because they still had an m in there. This one we said yes, it was. This one we said what do you say about that one? Are they right so far? No, because why? When they factor 8 out of 4, 8 will go into 4 0.5 times. That leaves you a decimal form, not an integral form, not completely factored form. I want you to tell me what the correct answer should be. What's our greatest common factor? 4x squared, y squared. What do you have left? 2. A little louder. No, there's no x. You pulled out the x squared. Y cubed, is that right? What next? Plus x. Plus x. Perfect. Way to go. Everybody see that? Okay, now the question is, well, I'm going to ask you this. What is that in completely factored form? Obviously, no. What can you pull out? 10. AB. They only pulled out 2AB. Guess what? Not going to be in completely factored form because they didn't pull out the greatest common factor. They factored it, but it's not completely factored. They still have a common factor there. So what is the completely factored form? What would you pull out? 10 AB. What would you have left? B squared plus 2 A to the third, close parentheses. You got it. Way to go. Now, do you see how you do these? We went beyond what they asked, okay? They say, which rule has been violated? You were, okay. You had a polynomial that still had, that wasn't in completely factored form. Here you had a decimal in it. And here you had not completely factored form. You still had a 5 in there. Okay? So yeah. You know what? In a while, I'm not going to care about what rule is violated. If you got a violation, just like those policemen out there. They're not going to care what your violation is. They're going to give you a ticket, right? So don't get a ticket. All right. Any questions? All right, here's the solution. The first one was no, not in completely factored form because the polynomial inside parentheses could be factored further. We factored it further. The B one was yes, completely factored form. You couldn't factor that remain polynomial any further. C was no, not completely factored form because the coefficient 0.5, not an integer. Okay? And D, no, not completely factored polynomial inside the parentheses could be factored further. You got all those, right? Any questions? All right. Now, sometimes the slides leave off examples that the book has, so let me make sure they're not doing, yeah, no, they're right on the money here. Now we're going to be factoring out the highest common monomial factor. Guess what? That's what we were doing. So let's continue. Factoring process we discussed in the section, this starts just like the other, often referred to factoring out the highest or greatest common monomial factor. That's what we were calling it. That's what it was. The key idea in this process is to recognize the monomial factor that is common to all terms. Now, guess what? If you don't recognize it the first time, but you factor a common out, then you look at the remainder and say, whoa, there's still another common factor. Factor it out, multiply it by the first monomial you pulled out. It works. You can take 2 steps, 3 steps, as many steps as you need. For example, we observed that each of the terms here has what? An x in it and a 2 in it. So what's the greatest common factor? 2x. And what do you have when you pull that out? Okay. Oh, they left it for us to do. All right. Good deal. Let's do it. Factor out the 2x, and what do you have left? X squared plus 2x plus, second? I can't hear.
3.
3. Okay, my hearing is so bad. All right, good deal. Now, I wanted to do a timeout on the previous page, and I forgot to. Let's go back to this. Whoops, too much. What do you notice here? I sort of hate they do this to you. Notice they put pluses in everything. And you get to thinking, oh, all these things have to be plus. No, they don't, you know. No, they don't. The earlier ones had things with minuses in it. And this one, again, all pluses. They don't have to be all pluses. Okay? So it says, thus we write that and insert within the parentheses the appropriate polynomial factor, which is, I hope you write better than I do, okay? X squared plus 2x plus 3, right? All right, we determined that the terms of this polynomial factor by dividing each term, remember, what undoes multiplication? Division. Factoring is another form of division. So you're dividing each term by the original polynomial, the greatest common factor of 2x. 2x will go into 2x cubed, x squared times. 2x will go into 4x squared, 2 will go into 2, x will go into x squared, x times. And 2 will go into 6 3 times, x will go into x 1 time. So there's your greatest common factor. You're really doing a division. You're doing it probably in your head, but that's what you're really doing is dividing. The following examples are further demonstrations of that process, so let's do them. Any greatest common factors there? Say again? Certainly a 2x squared would work. Is that the greatest common factor? Okay, 4x squared would work. I think that's it. When you factor out a 4x squared, what you got left in the first term? A little louder. 3x plus, don't forget the plus, 4 plus 4. Perfect. How about this one? Whoop, long one. Any common factors there? They certainly got a 3. X, y cubed. And when you pull out a 3x, y cubed, what you got left in the first one? 2x. Perfect. That was 3xy cubed. 2x plus 9y. Perfect. Way to go. Any questions on that? See how it works? Okay. All right, a few more here. Any common factors there? 2? Or not 2b? Never mind. Okay. What do you get when you factor out 2b? 4a? Minus. They finally got a minus. 9. Very good. How about this one? 4y squared. And when you pull that out, what do you have left? 2y plus 1. Excellent. Okay, how about this one? Big old long one. Whoa. If you need several steps, take them. What you see here? 6. X to the third. That's what we pulled out. You're reading my hand, aren't you? No, never mind. Okay. All right, what do you get when you pull out 6x cubed? 5 plus 7x minus 4 x squared. Excellent. Way to go. Any questions on that? Does it make sense? Okay. Huh? Okay. See? I finally got a little fuzzy look out there, and sure enough, no. What is it? Just, huh? You figure it out. Okay. All right. Confidence there. I like to see it. Okay. Are there questions? If you got a question, ask. Maybe we can think of an easier way to say it, a clearer way to say it. Any questions? Please ask. Note that in each example, the common monomial factor itself is not completely factored form. Okay? Yeah, that's 2 times b. This is 2 times y times y. I mean, who cares about that? The monomial. It's the binomial or the trinomial that we're interested in. Okay? So yeah, we could have written that 4x squared is 2 times 2. That's completely factored. 4x times x is completely factored x squared times that. But guess what? For monomials, we don't care. Write them as a monomial. It's the binomials and higher. Those we want to be completely factored. Any questions? All right. Now we get to do example 2. And they didn't do them for us, so you tell me. Do you see any common factors here in 3x fourth plus 15x cubed minus 21x squared? 3 certainly is one, and x squared is a common factor. Yes? Where does the square come from? Okay. All right. Good question. Okay? And here's how I approach it. I don't know if this is the best way. I look first at the numbers. 3, 15, and 21, and y'all picked out 3 right away. Forget about the numbers now and look at the variables. X to the fourth, x cubed, and x squared. What's the greatest common factor that's in all of those? Well, this has 4 x's, this only has 3 x's, this has 2 x's. So what's common to all of them? The 2 x's. So that's x times x, x squared. Okay? Oh. Why is it common? Because there's x squared will go into this, x squared will go into that, and x squared will go into that. And it's the largest variable term that will go into all 3. Does that make sense?
So the smallest one, will it always be answered?
No, not okay. The smallest common one, yes, is the. It has to be common to every one.
Okay.
Yeah, very good. That's a good way to look at it. Okay, what happens if you pull a 3x squared out of the first one? When I say pull it out, I mean divide it out. What do you have left of the first term? X squared. Okay. Why is that? Because x squared times x squared is x to the fourth. Now, if multiplying powers is something that's a little fuzzy, let's go back to chapters 1, 2, or the first part of 3. You might need to review that a little bit. When you're multiplying exponents, okay, terms with exponents, keep the base, add the exponent. Okay, that's how you get x to the fourth. Okay, next one. 5x. Very good. Next. Minus 7. Done. No, you pulled out the x squared. So you're left with just the minus 7. Does that make sense? Yes.
Okay. So after you choose the 2, you just throw away the 4 and the 3. The exponent is 4 and 3.
Okay. What you're doing is, you're dividing the numbers, subtracting the exponents. So you divide the 3 and the 3, that gave you a 1. You don't usually write down the 1. You subtract the 2 from the 4, that gave you a 2. Okay? Divide the 3 into 15, that gave you 5. And subtract the 2 from the 3, and that gave you 1. So you do write that. Now this one, divide the 3 into minus 21, that gave you the minus 7. Subtract the 2 from 2, that gave you 0. What is x to the 0th power? Anything in the world raised to the 0th power is 1, with one exception. There's no such thing as 0 to the 0th power. You can't do it, okay, so don't ever try. But 7,433,812.5 to the 0th power is 1. X cubed times the square root of 3x raised to the 0th power is 1. Anything raised to the 0th power is 1. That's why 2 minus 2, when you got a 0 there, x to the 0th is 1. You don't have to write the 1 down. That'd be minus 7 times 1. All right. Good questions, by the way. About this next one. Greatest common factor. 2. Oops. Ooh. Oh, I hate this. I'll have to get better. Okay. All right. Now I have to go back. I can't make mistakes because they take too long to correct. Okay. 2 X, Y. Why not? Okay. And what do you get? What do you have left in the first term? 4 X squared. Why not? Okay. Minus X squared. Nope. X to the third. That's right. Minus 6 Y. Perfect. Okay? That can't be factored any further. There's factors of 2 and 2 here, but no 2 here. X and X here, but no X there. Y here and here, but no Y there. Can't factor it any further. Okay? At least with greatest common factors. Okay? So there we have done it. Does that make sense? And remember, folks, if you're ever in doubt, go back and multiply. Multiply this. 3 times 1 is 3. X squared times X squared is X to the 4th. 3 times 5 is 15. X squared times X is X cubed. Minus 21 times X squared is minus 21 X squared. You can always go back and check. Okay? And make sure you did it right. If you don't get the same thing you started with, see where the error was. Sometimes the error is in the checking, sometimes it was in the original factoring. All right. Any questions there? Let's see how they did. All right. The first one, for each term in the polynomial, had a common factor of 3x squared. So we pull that out, and you're left with an x squared plus 5x minus 7. Yay, they got it right. Okay. The B one, each term in the polynomial had a factor of 2, x, and y. Factor that out, and what you have? 4 x squared y minus, pulled out the 2, pulled out the x, that gave you x cubed, pulled out the y, it's gone, minus 2 into 12 is 6, the x into x is 1, and y into y squared is 1. Perfect. Any questions? Does that make sense? All right. Let's make sure they're not skipping anything here. Oh, no, they're not. Okay. Now, factoring out the greatest binomial factor. Ooh. Yeah. Oh, okay. I thought there was a hand up. Okay. It was a stretch. Okay. In other words, I'm getting boring. No, I didn't say that. Okay. She didn't say that. I did. Okay. Sometimes there may be a common binomial factor. They may be a little harder to see than a common monomial factor. Guess what? The first few examples are going to be pretty obvious, okay? How about that one? Y plus 2. It's in this term and it's in that term. So let's factor it out, okay? And then what would we have left? If you factor out y plus 2, what would we have left? X plus z, parentheses x plus z. That's right. And that's exactly what we got here. Okay. Boy, when they do them like that, they're pretty obvious, okay? Consider an example that involves a common binomial factor. Let's do that, okay? Here's some. Common binomial factor in A here. What do you think it might be? B plus 1. Let's write that down just like we did for our before. And what is left? A squared plus 2. All right, I think I may have this down, okay? Next one. 2y minus 1. What's left? X minus y. Y'all are good. Okay? Next. X plus 2. What's left? X plus 3. Now, a little bit of a timeout here. When you're doing this kind of thing, and for right now, they're not going to sneak anything in on you. But I promise you, before the chapter's over, they're going to start sneaking. When you get it in here, then you stop and ask yourself, can this be factored any further? No. Can that be factored any further? And we don't have the tools yet to see it, but we'll say no. And you're right. That can't be factored any further. These two are pretty obvious. You can't be factored any further. But we can't just say, oh, this is factoring a common binomial. I'm through when I've done one step. Always ask yourself, can that term be factored any further? Okay? And we don't have the tools yet to determine that, but they can't. So let's see how they did it. The first one, they saw the b plus 1, greatest common factor. When they factored it out, left you a squared plus 2. All right? Any questions? The b one, greatest common factor, 2y minus 1. Factor it out, you're left with an x minus y. They did it right too. Good for them. And c, guess what? They even got 3 in a row. Factor out the x plus 2, that left the x plus 3. That's how you factor this. Okay? Make sense? Now, frankly, these, you have to be careful when you go back and multiply them back together because you're going to tend to do too much multiplying. So, but it still will work, but it's a lot more involved process. So I'll just leave that alone for now. All right. Now, they did the hard work for you on, they made example 3 pretty easy. But now we're going to start with factoring by grouping. Now, that's not grouping, it's grouping. Never mind. Okay. Y'all grouping, never mind. Okay, so what do we do here? It may be that the original polynomial exhibits no apparent common factor anywhere in it. Monomial factor or binomial factor, which is in the case of this one. Okay? Now, what is one thing you notice about this one that we probably haven't had before? Say again? 4 terms, okay? And guess what? To do factoring by grouping, you have to have an even number of terms. So when you see a 4 or 6 or 8 term polynomial, you say, where do we begin? Then you might say, hey, let's try factoring by grouping. Now, what we do here, we group these factors, like group these 2 together and those 2 together. Now, that's not factorization, that's just a grouping. But when we do that, what do you notice about those first 2 terms? They have an a in common. So you can factor that out of the first 2 terms. That would give you a times b plus 3. Now, in these terms, what do you notice you have? Common c, factor it out. That gives you c times b plus 3. You had a b plus 3 here, a b plus 3. Now we got something like we just had. And what do we do with that? Factor out the b plus 3 and left with a plus c. You just factored this. Okay? Way to go. That's exactly how you do factoring by grouping. Now, the other thing to watch. First thing you have to watch, you have to have an even number of terms. Second thing you have to watch, when you do your grouping, you've got to have a common factor. This problem would have been a bigger problem if they had done AB plus 3C first. Guess what? No common factors there. And you'd have been left with plus a 3A plus BC. No common factors there. But guess what? Terms can be manipulated. They can be moved past each other. So if you need to, do it. This one they set up for you. They kept it simple. Later they're going to throw in the other. I guarantee you they're sneaky that way. That's called factoring by grouping because the first thing you do, you group that big polynomial into smaller groups, factor out common factors for each group, see if you have anything left that can factor as a binomial. See the procedure? All right, let's try it. Whoa, here's some. All right, what about this first one? What might you do first? Group these 2 together and those 2 together. Okay? Now, that's not factoring, that's just grouping. Now, in the first group, what do you notice? You have a b squared in common, and what do you have left? A minus 4. Very good. Sorry. In the second group, what do you notice? You have a 3 in common with a plus in front, so plus 3 times, and what do you have left? A minus 4, look at that, okay? And what can you do now? All right, and she's doing it that way. It's perfectly fine. B squared plus 3 times A minus 4, okay? Factoring out the A minus 4 because it was common to both terms, and then what you have left over is B squared plus 3. Which I'll tell you, you can't factor any further. All right, that B one. What do you notice here? Okay, group the first two, group the last two. What do you do with the first group? Factor out at x. Excellent. And what do you have left? X minus 1. Y'all are good. Second group? Factor out of 5. And what do you have left? X minus 1. All right. What do we do now? X minus 1 is a common factor. And what do you have left? X plus 5. Excellent, excellent, excellent. Okay? Now, I'm going to do a little timeout here on this one too. I can almost guess that the first thing some of you might have done was say, wait a minute, we have a common, like terms here. Combine those together. And then you're not going to have a four-term polynomial. You have a three-term. You can't do grouping with three. You have to have odd numbers. We'll have a technique that we'll use for this that we're going to learn later. Not much later, but just a little bit later. But when they set it up for you this way, see if you can work it out. If you're not, then add them together. But if they set it up for you this way, go for it, just like we did. Now, this next one has a warning here. What would you do? Whoops, I got to get my pen back. Okay. What would you do first? Group. Now, here's a problem, folks. Group that way. I'm going to put back in my parentheses before. If that's a plus sign in between, it doesn't matter where you put the parentheses at all. But when you got a minus sign here, you have to include that in the group. You can't exclude it. The plus, you see, a plus, that, and plus, that's not going to change the sign at all. If you tried to exclude the minus, that would change the sign here. So with a minus sign, you have to include it. Now, that looks like a factorization more than this did. It's not. That's just a grouping. But let's deal with it the way we see it. Okay? What's common in the first group? X. And what's left? X plus 2. Excellent. Now, what's common in the second group? A negative 3. Pull that out. And what do you have left? X plus 2. You got it. Now, remember your rules for subtracting. For using minus signs. If you're dividing by a minus number, okay, remember this is dividing. Pulling it out is dividing. Divide a minus by a minus, what do you get? It gives you a plus. Oh, okay, I can't hear. Okay, sorry. It gives you a plus. So that becomes a plus, and that becomes a plus because you pulled the minus out. I feel like a dentist pulling it out. No. Okay. All right, next. What's the next step then? Next step. X plus 2 is a common factor. And what do you have left? X minus 3. Y'all are good. Really good. Okay? Now, let's see how they did it. The first one, they skipped a bunch of steps and make it look confusing, don't they? Okay? Maybe not. Maybe you can see that. But the first thing they did, they didn't show how you grouped it, but by putting the grouping sign in there helps me. And then you see the common factor of b squared, that gave you an a minus 4 here. And then when you group these two, common 3 plus 3, and you got an a minus 4. And then what do you do with that? And what do you get? A minus 4 times b squared plus 3. Very good. Okay? Now we'll go to the b. And again, they don't show the grouping. If they're going to call it factor by grouping, why don't they group? I don't know. Okay, so when you group these two, you see there's a common x with an x minus 1. These two, common 5 with an x minus 1. Now you have a common x minus 1. And what do you have left? X plus 5. Very good. All right. C. That's yes in Spanish. Okay, never mind. Okay, now what do you do here? Group This time, if it's a minus sign, be sure you include that in the group. It's okay to exclude the plus. That doesn't change anything. The minus would. So this has in its group.
So you always want to group the first two together?
I'm sorry?
You always want to group the first two together?
Okay. We'll see some examples of when no, you don't always. But when they're set up okay, do them. But when they don't work, then rearrange. Okay. So yeah, you could have rearranged this to begin with, and that would have been fine. You could have swapped these two and still worked it. You know, I wouldn't swap. You know, put these two together, you wouldn't have a group. But yeah, it really doesn't matter. But as long as the first two work, why do extra work? You see, I have a theory about being a good mathematician. Okay, I think good mathematicians are just inherently just a little lazy. Why? Because they're always trying to figure out the easiest way to do a problem. So if you don't have to move anything, don't. Okay, keep it the way it is. Now, do any of you qualify as a good mathematician? Or any of you a little bit lazy? No, y'all are all hard workers. Hard workers can still do math. That's fine. But, you know, if you're a little lazy, that gives you an edge. Okay. All right. Any questions on that? Did we get that done? We had done it before. Any questions? You need to see why that one? Okay. Common factor of x, x plus 2. Common factor, when you have the minus sign, pull it out. Okay, that would be a minus 3. What you have left, x plus 2. And then factor out the x plus 2, because it's the common factor, and you have x plus 2 times x minus 3. Make sense? Does that answer the questions? Okay.
It's gonna be on YouTube, right?
What's that?
You said it's gonna be on YouTube, right?
Yeah, it will be. I don't.
Okay.
I've got to figure out how to get the link done.
Okay.
But as soon as I do, it will be there on Black. It'll be on YouTube when I finish. But how to get it on Blackboard, I've still got to work that out. But I think that's an easy step. I've got a real good computer guy who's going to be my work study, I hope, and he knows how to do all this kind of stuff. So I think he's going to help me get that done. I might be able to figure it out, but I'm old and slow. Okay. All right. Now, here's to answer your question before. It may be necessary to rearrange some of the terms before you apply the distributive property. Terms that contain common factors need to be grouped together, and that may be done in more than one way. Okay, there's no one fixed way to do it. You can do it several ways. Here's an example. Okay, 4a squared minus bc minus a squared bc squared minus a squared b plus 4c squared. Can you group that the way it says? No, you could group it, but there's no common factors, are there? So therefore, you need to do some rearranging. What would you want to arrange together?
4a squared.
I like that. 4a squared minus a squared b, and then you have a minus bc squared plus 4c squared. And that's exactly what they did here. Okay? Except they actually did something else. They moved this all the way to the end. It doesn't matter. I would have just swapped these two and that would have been fine. But like I said, it doesn't really matter. Now we can group these two, and what do you have? A common factor of a squared. What do you have left? 4 minus b. And in this one, what do you have in common? A c squared. And what do you have left? 4 minus b. Now you can factor out the 4 minus b, common factor, and you have a squared plus c squared. Now we haven't done it yet, but I'll tell you, if y'all have had 098, you probably already know this. Sum of two perfect squares you can never, ever, ever factor. Okay? Ever factor, unless they have a common factor. Difference of two perfect squares? Yes, you can factor, but not a sum. So that's as far as you can go. Now that's what they call method 1. There's bunches of methods you can do. Okay, they took the second term and moved it to the end. Okay, method 2 was taking the fourth term and move it to number 2. That's fine too. And that works just as well. They took this term and moved it here and moved those two down. Okay? What do you notice here then? Group these two. You got a 4 times a squared plus c squared. Here, what do you have in common? Minus b. Always pull the minus sign out. Minus b times c squared. If you pull the minus sign out, that becomes a plus. Plus a squared. So, guess what? This and that are exactly the same because addition is commutative. It doesn't matter the order. Yes?
So, when there's a negative sign,
Yeah.
can I not just leave the plus and then put that negative back into the answer?
Okay. So you were saying pull out a plus b, and then you would have a minus c squared minus a squared.
Instead of grouping it with the negative sign, the minus sign, can I just group it without it and bring my negative sign down? Would it be the same answer?
I'll tell you what, you'll tend to make more errors that way. So I always include the minus sign in the group, and then pull it out of the group, changing the sign of both of those. See, that's what the minus does, it changes the sign of both. If you grouped it like that, that would then look like it's a b times c squared minus a squared. And it's not, because that minus sign needs to be part of the group. That's why. And it will tend to make you make errors. Okay? But the order of addition doesn't matter. What if this had been a squared minus c squared and c squared minus a squared? Can you just flop those? No. In order to flop those, you'd have to introduce a minus sign. But pluses, doesn't matter which way you do. Okay? So addition and multiplication are commutative. Subtraction and division are not commutative. So don't try. Okay? So therefore, they took one more step to rearrange the order there. Then they factored out the greatest common factor, which was binomial, a squared plus c squared, leaving with 4 minus b, which is exactly the same as we got here. Okay? And guess what? If it's the same problem you start with, you better get the same answer at the end. Okay. I see people beginning to move. Is that telling me something? 5 minutes? Oh, y'all are moving too soon. That's method 2. You could have had 3 or 4 methods, several of them. Yes.
Do you want to go to the whiteboard, walking us through it, and showing us exactly how you chose the form and all that?
Oh, method 2. Well, where is it? There it is. All right. Okay.
How you choose which group and whip.
All right. What they did, they saw the common factors of 4, so they pulled those two together. That would be a 4a squared plus 4c squared. What do they have left? Minus bc squared minus a squared b. Okay, whoops. Need to do, well, I'm going to do that next. Then let's group, but because it has a minus sign, include the minus sign in the group. Okay, and this one, what do you notice are your common factors? 4. What do you have left? A squared plus c squared. Second group, what do you notice is common? Not just the b, the negative b, minus b. And what do you have left? C squared plus a squared. Okay? Now you look at those and say, hey a minute, those don't look the same. Okay? But in reality, they are the same. Because a squared plus b squared, c squared is the same as c squared plus a squared. It would not be if that was a minus sign, but it is if it's a plus. Okay? You can take 4 apples and 7 apples. That's the same as 7 apples and 4 apples. You got 11 apples both ways. Okay? I think in terms of food. Okay? So, and then from there, common factor, a squared plus c squared, and 4 minus b. All right, I see too much motion now going on here. I'm beginning to get the hint. Where do we leave off here? We did example 3 2 different ways. No.
We went all the way
What's that? Okay. You know what? We skipped example. No, we didn't. Okay. So we're going to start next time. No, we did example 7. Did we do all the ones before that? I wasn't paying attention to the book. Okay. So we're going to start next time on page 148, which is using factors to solve equations. Yay! This is what we love doing. Okay. Now, let me give you a few homework exercises. I don't want you to have nothing to do. You would be really mad at me if I didn't give you a little bit to work on. Okay. So, we almost finished 3.42. Let's do any of the, do 1 or 3. Any of the odds 5 through 41. There's a whole passel of those. This is on page 150. Okay? Do either 1 or 3, any of the odds 5 through 41, and then factoring by grouping, any of the odds 43 to 63.
What do you mean?
Second? Okay. Do 1 or 3. Okay. Time out. Okay, let me tell you. Yeah, odd numbers. But you don't have to do them all. When I say any of them, do some of them. You say, oh, I got this down. Move to some harder ones. Oh, I got that one. Move to some harder. I say do as many as it takes for you to feel comfortable. Say, I got this. I got this. So it's up to you. Okay? So do as many as it takes. If you need to do them all, do them all. But if you got, and say, hey, I can do those. Let me skip down and do a little harder ones. You got those? Skip down and do some harder ones. It's up to you. Okay?
So you said
this
1
is
or 3 and then
1 or 3, any of the odds 5 through 41, and any of the odds 43 to 63. Stop there. That moves on to page 151 a little bit. Yeah. All right. Good deal. Okay. And Gay, please do them. How did Kobe Bryant get to be a pretty good basketball player? He shot and shot and shot and shot and shot. So, yeah. Okay. Good deal. We'll see you Wednesday.